Oh, that's a very code-rich slide title, isn't it, or lecture title, but it'll all come clear in a moment. So, in this video, we're going to talk about the importance of knowing your data types. Here you go. It's important you know your data types. We'll be introducing the standard map data type. We will immediately substitute TMap for that so that we keep things Unreal. We're going to write things how Unreal wants us to. They have a structure called TMap. We talk about how we'll be using the map. Basically, like that is how you declare the map. You say that I want a map, which is just a table of characters against booleans. So this is, have I seen a letter? Letter A, yes. Letter C, yes, etc. And then we'll tell you how to use it, basically like that. Letter seen brackets the letter. We'll access the letter and return a boolean. So have I seen A? Have I seen B? So this simply allows you to say things like, I've seen letter A, I've seen letter B. Have I seen letter A before? Have I seen letter B before? And then we'll be wiring up and pseudocoding is isogram. So see you in a moment. So just before we start, if you do a Google search for UE4 libraries, you should find this blog post from April 2014 by Billy Brammer that just overviews Unreal's data types that we have access to. Containers are things that contain multiple items, of course, like an array, which we'll deal with shortly, a T-set, which would be a perfectly valid alternative, by the way, for this video. We could use a T-set. I'm going to be using a map, which is very similar to a set, a little bit more complex, but a little bit more general, which is why I'm going to teach it here. And then it talks about a couple of other things, including strings that we've seen before, fstring, ftext, etc. So worth a quick look at that, and let's dive in. We're going to do ours based on map, as I say, because it's more general. So let's show you what a map is by example of how we're going to use it. So we're going to use the word happy. I've purposefully made the A and one of the P's uppercase because we want to be able to handle this type of mixed case. Follow me through one line at a time. So a map is a key with a value. We're going to have the keys as characters and the values as booleans, and we're going to translate all our characters from uppercase to lowercase. So we're going to store just lowercase. So this is what we do. We get to H, we store an H, and we say value. We've seen it, true. We have an A. We translate it down from the capital A to the small a and put an A in the table, just saying we've seen an A. Then we put a lowercase p because we've got a lowercase p. We've seen a P. When you get to the second P, you translate it from uppercase to lowercase, and we already have a value of true, so our algorithm's just going to say, well, we've already seen this letter, let's dive out of here, let's just leave the function. Okay, so it's as simple as that. You literally are putting you're just keeping track of which letters you have seen. It's as easy as that. Okay, so if you want to find out more about maps, you can do it in two places. If you want to find out about the standard maps that, of course, we're using here, because we're not inside Unreal yet, then it's stdmap, and you can go and have a look on c++.com. You've got a couple of different articles here, and it will show you how to use it. Looks a little bit cryptic. You're probably better off finding some example code somewhere. In here, for example, you see some example code. So this is defining the map, a map of a character and an integer, very similar to us, but we're going to be having a boolean here, and they're calling it first. We're going to call it letter seen. And then they're assigning things to it like this. So they're saying first, the letter equals 10. So that's a map. It's just a pair of values. Okay. There's also the Unreal map, and that's called a TMap. And we're going to make a substitution so that we use the word TMap. And here is one example of finding out about TMaps. TMap there, and they tell you all about it. Now, you add to things in Unreal a little bit differently using .add. We're going to just use the previous syntax we saw over here for now, and we'll adjust our strategy in Unreal. Okay, so that's an overview of maps. They are relatively simple. Let's dive in and start getting that working. The first thing you're going to need to do is make the map library available. So we need to do a hash include of something called map. Now, I'm going to put it here underneath because I immediately want to do a define, a hash define. Now, a hash define is literally a preprocessor directive like hash include for cut and paste. Hash include basically goes to an external file like a standard library map or this thing we've written. Hash define is even simpler than that. Hash define, let's just look up the syntax. Hash define C++. C++.com will do. The identifier and the replacement, and it's a textual replacement. Okay, so the identifier we want to use is TMap because that's the Unreal way of doing things. And what we want to replace, the replacement is stdmap, which will now be available because we've hash included TMap, map rather. So these two lines I think go together, okay? So we're going to use TMap because we're writing Unreal Standard T++. Unreal has its own data types that override the standard libraries because they're more suited to the sort of platforms that we're going to deploy on when we make games in Unreal. So we make that substitution, hash define TMap standard map. Great. Now you may be wondering why we're not using like we did a couple of lines below. The reason is twofold. Number one, I want to introduce you to more things, in this case hash define, which is simply a cut and paste, and you'll be seeing that in Unreal. The other thing is that using would actually be more complicated in this case because we'd need to get involved with parameters, and we just don't need that complication right now. So it's simply an alternative, and I want to widen your knowledge base. All right, so let's now start laying the foundations for doing this. Let's give you your first challenge of this video. I want you to wire up isIsogram. Create yourself a private function inside the class, decide if it should be constant or not, call it from check guess validity, and simply return true for now inside isIsogram. isIsogram is going to be an empty function, okay? And your game should behave exactly as it does now. It's just that it's calling this empty isIsogram function. So go ahead, pause the video, and wire up isIsogram right now. Okay, welcome back. So let's start in our header file. We're making a supporting function for the first time. It's exactly the same as these variables, but this time it's a function. What is it going to return? A Boolean. What's it going to be called? Isogram. What's it going to take in? An F string, because we're not dealing with user interface text. And is it constant? Yes. If I ask the word isIsogram, I don't want to be changing any data or fields or member variables of this class, do I? I'm just asking a simple question. Space this out a little. So bool isIsogram. Let's go ahead and implement it. This is all revision for us. So that's in the C++ file, isIsogram. I said I wanted it to return true in the challenge slide, so let's do that. And the reason is that where we call it up here, we're going to say if not isIsogram. Passing in the guess. If the guess isn't an isogram, yes, it matches the comment. That's fantastic. All right, so if not isIsogram guess, then we can get rid of this to do because we are in the process of writing isIsogram. Let's check that our code runs as it used to. If I put in AA, it says enter a 6-letter word. If I put AB, 6-letter word, boom, okay. So it's running as it did before. I have a second challenge for you, focusing our attention on the isIsogram method. By the way, one way of jumping around your code is to click the name of the method here and hit F12. Or if you right-click, you can see that shortcut there, go to definition. Useful one for jumping around your code. So what we're going to be doing in here is asking you to pseudocode isIsogram. Only write comments, indent the comments as they're needed, avoid code in the comments working at a high level, and run through mentally with some examples. Now we're going to be using the hash table solution to this, as you may have guessed with map. This is, as I said in the table example, we're just going to go through the word, keeping track of the letters we've already seen. Very natural, very much like as a human does it. So pause the video, and pseudocode only isIsogram now. So welcome back. Let's pseudocode this. Well, firstly, I want to think about the extreme cases. What happens if they send in a blank string or a string of just length 1? We need to make a decision on what that would do. If we're running a game and I put in nothing, what do we want it to say? Something like enter a 6-letter word. Even if I put in a single letter. How about if I put in /0? Anyway, we'll worry about that in a bit. So a single letter or an empty string, I think, should be considered an isogram so that it falls through to the correct word length, because you can't have repeating letters in a 0 or 1 letter word. So consider or treat, treat 0 and 1 letter strings or words, let's call it, as isograms, which is probably going to mean return true. I may as well have something here to hang on to, a variable name called word. Then what are we going to do? We're going to loop through all the letters of the word. And then for each letter, we're going to say if the letter is in the dictionary or in the map, we are just going to, well, then we do not have an isogram, which is probably going to mean return false, but I don't want to write code here. Otherwise, we're going to add the letter to the map as seen. So I'm going to add the letter with true. Then what are we going to do if we did get down to the bottom here? We should never really get to the bottom here because one of these two things should end up happening, but the compiler will complain if we don't leave something like return true at the bottom because it won't realize that all of these code paths are jointly exhaustive. So actually, if the user entered /0, that's the escape character to say that's the end of a string. And what would actually happen, depending on how you implement your loop here, is it would probably not go through this loop at all, and it would probably end up getting down here. Because if you're, depending also how you implement this, you might here say if word.length is less than or equal to 1 or something. Well, if you put in /0, it'll probably jump through both of these. So I think it's a reasonable thing to actually say that if we make it to the bottom, we return true. For example, in cases where /0 is entered. It's a very esoteric case. We do need to think about the fact that we could end up there. So I'm going to return true and just leave that there. So that's my pseudocode, and it's as, I say as simple as that, really, but it's a simple loop. Now, in the next video, we're going to talk about how you loop through all the letters of the word, because we showed you how to do it kind of brute force, where you use your own iterators and stuff. But come on, there's got to be a better way, and there is a better way, and that's called a ranged for loop, which is going to automatically go through all the letters without us worrying about the details of how many letters there are. So that's what we're going to look at next.